Welcome to Lesson 7, Creating Your First Database. Create your first database in SQL Server. Today is an exciting milestone. In this lesson, you'll stop just exploring SQL Server. You'll actually create your very first database. In this lesson, you'll discover what is a database, why every application needs a database, how to create a database in SQL Server, how to rename a database safely, how to delete a database correctly, real-world tips and best practices. By the end of this lesson, you'll have the confidence to create and manage databases on your own. Let's build your first SQL Server database together. Welcome back. In the previous slide, you saw what we're going to learn in today's lesson. Now, let's begin with the most important question. What is a database? Before creating a database, we must first understand what a database actually is. Let's think about a real-life example. Imagine you're running a small supermarket. Every day, customers buy products. You need to store information such as customer details, product information, sales records, employee details, supplier information. Can you remember all this information in your mind? Of course not. Can you write everything on paper? Yes, but after a few months, finding specific information would become difficult. This is where a database becomes essential. A database is an organized collection of related data. It stores information in a structured way so that we can easily store data, search data, update data, delete data, retrieve data whenever needed. Think of a database as a digital filing cabinet. Instead of paper files, it stores information electronically. Instead of searching through hundreds of paper documents, SQL Server can find the required information in just a few seconds. That's why almost every modern application uses databases. For example, banking systems, hospital management systems, school management software, shopping websites, food delivery apps, railway and airline reservation systems. Behind every one of these applications, there is a database storing and managing information. So remember this simple definition. A database is an organized collection of related data that is stored electronically and can be accessed, managed, and updated efficiently. This is the foundation of everything you'll learn in SQL Server. In the next slide, we'll create our very first database using SQL Server Management Studio. Let's get started. Welcome back. Now that you understand what a database is, let's create your very first database in SQL Server Management Studio. Open SQL Server Management Studio and connect to your SQL Server instance. Once the connection is successful, look at the Object Explorer on the left side. Find the folder named Databases. This folder contains all the databases available on your SQL Server. Now right-click on the Databases folder. A shortcut menu will appear. Move your mouse to New. Then click Database. The new database window will open. This is where we'll create our first database. You'll notice a field called Database Name. This is where you enter the name of your new database. Let's type the name, JeyBTechAcademy. You can choose any meaningful name for your own projects. For example, StudentDB, SchoolDB, HospitalDB, InventoryDB, SalesDB, EmployeeDB. For now, we'll use JeyBTechAcademy. Below the database name, you'll see several advanced settings. Don't worry about those options today. SQL Server automatically provides the recommended default values. For beginners, the default settings are perfectly fine. Simply enter the database name and click the OK button. Within a few seconds, SQL Server creates your new database. Congratulations! You've just created your first database. Look at the Object Explorer again. Expand the Databases folder. Can you find JeyBTechAcademy in the list? If your answer is yes, fantastic! You have successfully created your first SQL Server database. In the next slide, we'll explore the newly created database and understand the folders that SQL Server creates automatically inside every database. Let's continue. Now that we've successfully created our database, the next question is, how do we check whether it was actually created? SQL Server provides a system catalog called SIS, databases. Think of it as SQL Server's internal directory that keeps information about every database available on the server. In this query, we use the select statement to retrieve only the name column from the SIS, databases catalog. Let's read the query together. Select name. This tells SQL Server to display the database names. From SIS databases. This tells SQL Server where to retrieve those names from. Here, SIS databases is a built-in system catalog maintained automatically by SQL Server. When we execute this query, SQL Server returns a list of all available databases. You'll usually see the four system databases: Master, Model, MSDB, and TempDB. Along with them, you'll also see the database that we created, CompanyDB. This confirms that our database has been created successfully. One important point to remember is that this query only displays information. It does not create, modify, or delete anything. It is simply used to view the databases available on the SQL Server instance. As a SQL developer or database administrator, you'll use this command frequently to verify existing databases and ensure your newly created databases are available before moving on to the next steps. Select name. From SIS databases. Can anyone identify which part specifies what to retrieve and which part specifies where the data comes from? So far, we've learned how to create a database and how to view all the databases available in SQL Server. But before we can create tables, insert data, or write queries, there's one very important step. We must tell SQL Server which database we want to work with. We do that by using the use command. In this example, we write, use CompanyDB. This command tells SQL Server to switch the current working database to CompanyDB. Think of it like entering a building. Imagine a city with many office buildings. Before you can work inside one of them, you have to enter the correct building. Similarly, SQL Server can contain many databases, and before performing any operation, you need to select the correct one. Once we execute the use CompanyDB command, every SQL statement we write will run inside the CompanyDB database until we switch to another database. For example, when we create a table, SQL Server will create it inside CompanyDB. When we insert records, those records will also be stored inside CompanyDB. If we accidentally select the wrong database, our tables or data could end up in the wrong place. That's why experienced SQL developers always verify the current database before executing important commands. Although the use command is very short, it plays a crucial role in SQL Server because it defines the context in which all subsequent SQL commands will execute. Use CompanyDB. What do you think will happen if we create a table without selecting the correct database? The table may be created in a different database than the one you intended. That's why using the use command is considered a best practice before performing any database operations. Use changes the current working database. It does not create a new database. All subsequent SQL commands execute within the selected database. Always verify you're working in the correct database before creating tables, inserting data, or making changes. The use command helps prevent accidental operations in the wrong database. Golden rule. Always select the correct database first, then execute your SQL commands. So far, we've created a database, verified that it exists, and selected it using the use command. Now we're ready for one of the most important steps in database development, creating our first table. A database by itself is simply a container. To actually store information, we need tables. Think of a table as a spreadsheet. It contains columns, which define the type of information we want to store, and rows, which hold the actual records. In this example, we're creating a table named Employees. Let's understand the SQL statement one line at a time. First, we write, create table employees. This tells SQL Server that we want to create a new table called Employees. Next, inside the parentheses, we define the columns. The first column is Employee ID primary key. Here, Employee ID is the column name, INT means it stores whole numbers, and primary key means every employee must have a unique ID. No two employees can have the same employee ID. The second column is name nvarchar, 100 not null. Nvarchar, 100, allows us to store text with a maximum length of 100 characters. The not null constraint means every employee must have a name. This field cannot be left empty. Next, we have department nvarchar, 50. This column stores the department name, such as IT, HR, Finance, or Sales. Finally, we have salary decimal, 10-2. This data type is used to store numbers with decimal values, making it suitable for salaries, prices, and financial data. Once this command is executed, SQL Server creates the employees table inside the currently selected database. At this stage, the table structure is ready, but it doesn't contain any records yet. We've only defined what information each employee record should contain. In the next lesson, we'll learn how to insert actual employee records into this table. After displaying the SQL statement, explain it from top to bottom instead of reading the entire code at once. Point to each line and say, create table creates a new table. Employee ID unique identifier. INT whole numbers. Primary key no duplicate values. NVRCHAR text data. Not null value is mandatory. Decimal 10-2 numbers with 2 decimal places. Then ask the class, if 2 employees are assigned the same employee ID, will SQL Server allow it? No, because employee ID is defined as the primary key. SQL Server automatically prevents duplicate values. Key points to emphasize. A database stores one or more tables. A table is made up of columns and rows. Create table defines the table structure. Every column has a name and a data type. Primary key ensures each record is uniquely identified. Not null makes a column mandatory. The table structure is created first, the data is added later. Golden rule. First create the database, then select it using use, and finally create your tables inside it. Great, we've created our database, selected it, and created our first table. The next question is, how do we see the data stored inside that table? That's where the select statement comes in. In this example, we're using the following query. Select star from employees. Let's understand what each part means. First, we have the select keyword. The select statement is used to retrieve data from a table. Next, we see the asterisk symbol. The asterisk means all columns. In other words, SQL Server will return every column available in the employees table. Finally, we have from employees. This tells SQL Server which table to read the data from. So when we execute this query, SQL Server reads every row and every column from the employees table and displays the result. On the right side, you can see the output. Each row represents one employee, and each column represents a specific piece of information such as employee ID, name, department, and salary. This is one of the most frequently used SQL statements because developers use it to verify data, understand table contents, and check whether records have been inserted correctly. Although select asterisk is very convenient while learning and testing, in real-world applications, we usually retrieve only the columns we actually need. This improves performance and reduces unnecessary data transfer. We'll learn that approach in the upcoming lessons. Teaching tips. After displaying the query, select star from employees. Explain it line by line. Select right arrow retrieve data. Asterisk right arrow return all columns. From employees right arrow read data from the employees table. If the employees table has 10 columns, how many columns will select return? Then explain. all 10 columns. The asterisk tells SQL Server to return every column in the table. Key points to emphasize. Select is used to retrieve data. Star means all columns. From specifies the table to read from. Each row represents a record. Each column represents an attribute of that record. Select star is useful for learning, testing, and verification. In production applications, prefer selecting only the required columns for better performance. Golden rule. Use select while learning and exploring data. As your SQL skills grow, retrieve only the columns you need. In the previous slide, we learned how to retrieve all the columns from a table using select asterisk. But in real-world applications, we usually don't need every column. Most of the time, we only need specific information. For example, imagine your manager asks you to prepare a salary report. They only want to see the employee names and their salaries. They don't need the employee ID or department. In that case, instead of using select asterisk, we can specify exactly which columns we want. Here's the query. Select name, salary. From employees. Let's understand it step by step. The select keyword tells SQL Server that we want to retrieve data. After select, we list the column names we want to display. In this example, we've requested only name and salary. Then we write from employees, which tells SQL Server to retrieve those columns from the employees table. When this query is executed, SQL Server returns only 2 columns, name and salary. Notice that columns like employee ID and department are not displayed because we didn't ask for them. This approach has several advantages. It makes the results easier to read, reduces unnecessary data transfer, and improves query performance, especially when working with large tables. As a beginner, it's perfectly fine to use select asterisk while learning. However, as you become a professional SQL developer, you'll find that selecting only the required columns is considered a best practice. Select name, salary. From employees. Explain it line by line. Select retrieve data. Name, salary, return only these 2 columns. From employees, read the data from the employees table. Will employee ID appear in the result? No, SQL Server returns only the columns that we specify after the select keyword. Real-world example. Imagine you're preparing a payroll report. The finance department only needs the employee's name and salary. Showing employee ID, department, address, phone number, or date of birth would only make the report longer and harder to read. That's why professional applications retrieve only the information that's actually needed. Key points to emphasize. You don't always need every column in a table. List only the columns you want after the select keyword. Columns are separated by commas. SQL Server returns only the requested columns. Selecting fewer columns improves readability and can improve performance. This is the preferred approach in real-world applications. Golden rule. Retrieve only the data you need, not all the data that's available. Congratulations! You've successfully completed Lesson 7 of our SQL Server course. In this lesson, we learned some of the most fundamental concepts in SQL Server. We started by understanding how to create a new database using the Create Database command. Then we learned how to verify the available databases using the SIS, Databases System Catalog. After that, we selected our working database using the use command. Next, we created our very first table and understood how tables are designed using columns, data types, and constraints. We also learned how to retrieve data using the select statement, how select asterisk returns all columns, and finally how to retrieve only the specific columns we need. These concepts form the foundation of almost every SQL application you'll build in the future. I encourage you to practice each command on your own computer. The more you practice, the more confident you'll become. If you found this lesson helpful, please take a moment to like this video, share it with your friends, and subscribe to JeyBTechAcademy for more SQL Server lessons. Don't forget to turn on notifications so you never miss an upcoming lesson. In our next lesson, we'll learn how to filter data using the where clause and retrieve only the records that match specific conditions. Thank you for watching. Keep learning, keep practicing, and I'll see you in the next lesson. Closing message. Every SQL expert started by writing their very first query. Keep practicing, stay curious, and success will follow. See you in Lesson 8.